Hi, I'm Azure D. Schleicher with Ocean and Coastal Consultants out of Trumbull, Connecticut, and I am a coastal engineer. I still don't have all the answers, a lot of questions, but prior to joining here today, I was asked to ponder a few things. What are the reservations that coastal engineers have with respect to living shorelines? What are some of the reservations that owners that we represent as consultants have about living shorelines? And what are some of the incentives and things that could be done from a regulatory standpoint and from a design criteria standpoint that could help promote living shorelines here in Connecticut. So we heard today a lot, and I apologize, I missed the first couple of presentations this morning, so if I say go over some of the keywords and some of the concepts that were discussed earlier, I apologize. But we don't have a lot of living shoreline projects in Connecticut that are a proactive approach to erosion. We have lots of marsh creation and wetland creation projects that may have been part of a mitigation compensation for other types of projects, but as a proactive living shoreline, we don't have a lot. Why is that? Again, there's a lot of questions and not a lot of answers, but from my perspective as an engineer, there's definitely a lack of design criteria. As a coastal engineer, if someone says, I want a bulkhead, I can determine wave loads, current loads, wind loads, all of those environmental factors that will affect that structure and design the structure appropriately. If someone says, I want a living shoreline, I don't know what to do with those loads, and I'm pretty darn sure, especially as we get into the higher energy environments, which we talked about already, some of those loads that a structure or a living shoreline would be susceptible to, a stand of Spartina is not going to tolerate. So there's definitely a lack of design criteria out there. The need for maintenance, again, that was discussed, but you can't just install these living shorelines and walk away. So you have to be able to maintain them. And the term that we've been using in other locations is adaptive management. Being able to see the flaws in a project as it progresses and say, okay, maybe a stone size for the sill is a little undersized. How can we improve that and have the flexibility in a permit and under the regulatory regime to be able to go and do that and be adaptive, as the project proceeds. The level of protection of these softer solutions versus harder solutions. Again, as an engineer, there's a lot of information out there, guidelines, criteria that we can say, we have 100-year storm waves and environmental conditions, and this steel sheet pile bulkhead, with the strength of that steel, can withstand those. And I can't say the same thing for vegetation and other softer materials. So your level of protection is a lot less. Also, we heard today that living shoreline is good for erosion, not necessarily great for flood control, storm surge. So you're, again, someone as an engineer, more prone to suggesting a bulkhead or a riprap revetment that I know is going to be able to protect greater against storm surge and flood control. And then what I've seen this past year has been a very narrow definition of living shorelines, especially here in the state of Connecticut. What I heard today was a broad definition of living shorelines, but the interpretation, especially within DEEP so far, has not been as broad as the definition presented. And the owners, and as a consultant, I deal with a lot of private homeowners in the state of Connecticut and some smaller commercial yacht club, those types of owners, not so much the municipalities, but we're talking about small spaces. And in order for these living shorelines to work, it needs to be more community-based, an entire street perhaps. Not just a 50-foot or 100-foot lot. It's certainly not going to provide that level of protection. So again, from an owner's perspective, what is their, 5-foot wide strand of Spartina over, a 50-foot lot really going to do for them for flood and erosion control? There's a real lack of local examples So when I'm talking to my client down in Greenwich and he's, where else is this done? It's done in the Chesapeake. Well, that isn't really giving him a good level of comfort. And again, when it comes back to design criteria, as an engineer for a hard structure, I can put on the drawings what that structure is designed to. It's much more difficult to do on a living shoreline project. And so there's less of a guarantee. Should the living shoreline fail, or there's need for more frequent maintenance than we anticipated. How's the owner going to come back and say, "Hey, you didn't do what you told me you were going to do"? Well, it's really hard for me to give you a guarantee in the first place. And then again, we talked about, or someone talked about it a little bit before, the slopes and the availability of land to implement a living shoreline. Again, with a lot of private property having a hardened shoreline and no one really wanted to lose their backyard and things like that, it's harder to promote a living shoreline concept where someone might have to flatten out a slope or with sea level rise. I mean, the one good thing about living shorelines is that they will adapt with sea level rise, but that also means that as sea level rises, the high tide encroaches and the wetlands encroach onto somebody's property, now they've lost some usable space within their backyard, and then they can't mow it, and all of a sudden now they can't put in a pool because they have a wetland in their backyard. So those are the types of reservations that I, as a coastal engineer, have, and also that I've heard from the owners and clients that I represent. So lack of design criteria and standards. We talked a lot about environmental condition, waves, including boat wakes, currents. Ice is a big one. We haven't heard much about that today, but here in the Northeast, it's a big deal, and it could be a plant killer. Slope, we've heard about, soil conditions, plant species. I'm a coastal engineer. I'm not a biologist or a wetland specialist. I know enough to be dangerous, but I don't know enough about plants. If we had, better references or something that I was, more aware of, that as an engineer I could go to understand, what species of plants are best in what conditions, would definitely be helpful to me as an engineer. The optimum dimensions for various shoreline configurations and conditions, sills, should they be X feet above the mean high water or below, something like that if there were some criteria. And also metrics for monitoring. We've heard about we need to monitor. Well, what are those characteristics that we're monitoring for, and what is this criteria that we're going to measure success for or failure? I've had the pleasure of working with the New York State DEC over this past year. They have a Hudson River Sustainable Shorelines project that they've been working on for many years, and this year they had, back in 2013 and 2014, they had a grant, and they commissioned Stevens Institute of Technology to undergo a forensic study of various types of living shoreline projects that were done up in the Hudson River estuary and parts of upper New York City area in the Hudson River. And I was part of an engineering panel that was involved in that project, commenting and reviewing the research and evaluation that the grad students at Stevens Institute were pursuing. And there were a few takeaways from that study. And a number of common factors for failure were debris impacts. And again, that's something storm-related that a lot of times are not accounted for, but in Sandy, that was a huge impact and on not only living shoreline projects, but also structural solutions, seawalls and other shoreline structures. Understanding and the graded stone. If a lot of the typical definition of a living shoreline is a sill. And what is the criteria for rock, and the common failure mechanism was undersized rock. And again, it gets back to the design criteria. As a coastal engineer, if I'm designing a revetment, I could say my wave height is 3 feet, and that correlates to a stone size. But that stone size is going to be, 2.5, 3 feet. That's not the same kind of stone that you would want for a living shoreline sill. Otherwise, it turns into a breakwater. So we have to be able to find that balance. But the common failure mechanism in a lot of the projects that were investigated in this study were undersized stone. Slopes, again, we talked about that, but the ideal slope that they found was 1 on 10. Certainly more steeper slopes. Trying to force fit a living shoreline project in an area that's too narrow those projects failed during these major storm events. Again, not accounting for ice and floodwater recession. We always think about what's going to happen as the flood comes onto the structure or shoreline, but when the floodwater recedes, sometimes that force is just as great. And if you don't have a mechanism or a way for that floodwater to recede, it can cause as much damage as when it came in. Several common factors for success: development and implementation of a monitoring system with maintenance, adaptive management. Again, that's I've heard adaptive management to be more of a negative thing in some permitting. Say, if your project is shown to do this, then you'll take it out. Well, adaptive management in this respect is, finding the flaws and fixing them in a positive way, not removing the system entirely. And the maturity of the vegetation. Certainly, if, in some of these projects, Sandy came in, a couple of months after that vegetation was just planted, it didn't work. In some of the areas that the vegetation was more established, they thrived. And some of the ways to temporarily stabilize that vegetation through core logs or some other mechanism so that it has an opportunity to root and thrive was really part of the success for these projects. But the underlying theme for this whole entire forensic study is more research is needed. And that we need to install these projects, whether or not we have the design criteria now. We still need to work on these projects. We still need to get them installed so that we can monitor and understand the performance and be able to derive these physically based design criteria. So I'd like to just talk about a few projects that I've been working on. This one is in Connecticut, Cedar Point Yacht Club, and I consider this to be, from my company's perspective, to be the first living shoreline project that we're proposing in Connecticut. Again, we've done a ton of mitigation projects, marsh creation, as a result of doing other work. But this one is an eroding bank in a somewhat stable, sheltered marina basin in Westport. You could see the pictures. On the left, you could see where some of the existing vegetation is being undercut, and on the right, there's some areas that are just devoid of vegetation altogether. Just landward of this bank is a road, which is the only road that accesses this yacht club and also several residences in the area. So the club wanted to do something about it. They wanted to be proactive. Certainly the erosion is not that great right now, but we also don't want it to get that bad where we have to do something more than a living shoreline, where we have to do a riprap revetment or a bulkhead. And with the regulations as they stand now, we felt that if it were to get to that point, we would be able to, under the statutes, get a hardened structural solution because of the infrastructure that it would be protecting. But again, we wanted to be proactive, and so we proposed what we consider to be a living shoreline. This photo on the left, this Gabion mattress, 6 inches thick, filled with rock, in which vegetation would thrive and grow. That is what our original proposal consisted of. During the pre-application process, it was rejected as a living shoreline. And the immediate reaction of DEEP was put in a sill. And well, there's more to living shoreline than just sill and vegetation planting. And so we worked through it, And the photos on the right are what the proposal is now. This is not the actual site on the right because the permit is actually pending right now. But we substituted out the Gabion mattresses for a Quar mattress. Again, 6 inches thick, very similar to the Gabion, but the Quar mattress is biodegradable. So, at the end of 2 or 3 years at the most, that material will have degraded, and hopefully vegetation will be thriving throughout. And at the base of the bank, we would put a Quar log again to help stabilize as vegetation grows. So one of the other things I was asked to discuss was incentives for increasing the frequency of living shoreline proposals in Connecticut. Again, design criteria would be great, but again, I urge us not to wait until we have it. We need to be able to get these projects in, even if they're pilot studies, so that we can get the data we need to develop the design criteria. Certainly, general permit eligibility or shorter time periods for review would help. Allowances for adaptive management in the permits. The increased ability to try something more robust if there's repeated failures. And I guess this gets back to the owner's reservations. We know that living shorelines could be susceptible to a lot of damage. How many times is someone going to replace a living shoreline or do that maintenance before we just say, hey, this is not the right site for that? And can we move on to something a little bit more robust, a riprap revetment or something like that? Certainly grants would help. I know a lot of people who would love some grant money to go ahead and do a pilot study. And most importantly, I think open-mindedness for potential alternatives and an expanded definition of what a living shoreline is. And what they're using in New York City rather than living shoreline is green infrastructure, which encompasses a number of different types of solutions, including oyster breakwaters, vegetative floating wave attenuators, and ecologically enhanced bulkheads and revetments. And so just quickly, I'm just going to run through a couple of projects that OCC is working on in other locales, which we consider to be green infrastructure or have some kind of living shoreline component. This one is a floating wave attenuator island, and you can see there's a schematic view. This has actually been permitted for Jamaica Bay in New York City by the New York State DEC and the Army Corps of Engineers, and is likely to be installed sometime this spring. Rebuild by design, living growing breakwaters in Staten Island. OCC was involved as the coastal engineer for this project, in which it's a traditional rock breakwater, but it's enhanced with ecological concrete to enhance oyster development and growth in the bay. And we're currently working for the Nature Conservancy down in southern New Jersey on Delaware Bay for a living shoreline, which has a very small component of actual tidal wetland vegetation creation through the use of Quar logs and fill. But the majority of this project is an oyster breakwater in various configurations and types, from shelled bags to the ecologically enhanced concrete to proprietary units called oyster castle, so almost like Legos that build up to form mini breakwaters. And we're in the infancy of this project, but we have had good feedback from the regulatory agencies down there that this is considered a living shoreline and likely to be eligible for their new general permit down in New Jersey. And so again, I urge especially the regulators in this room to be more open-minded about what they consider a living shoreline. I think that's it. Yep, that's it. So I'll just pass it on.
Thanks.